Same YouTube.
Yeah, for Sana I'm recording. Okay. Okay. So I think in the last previous section we saw prompt engineering also, one shot, two shot template. Okay, because there is one concept in GenAI or when we are working with LLM that is called as LLM hallucination. Okay, sometimes now a chat GPT models, it may be, or Gemini, it may be any kind of large language model, it hallucinates. Why it hallucinates is because we don't give it enough prompts. Okay, if I just ask ChatGPT write a professional email asking for a leave, that's it. It doesn't know what to give the correct answer. So something it will pick randomly. It will give something. That is what hallucination is. Okay, so in order to avoid that hallucination, we have to give proper prompt with proper details. Okay, write a professional email. Okay, to my manager requesting for a review. This so and so reason. This is what the company is. So complete. If we give few short prompts, so exactly it will generate according to it. That is what prompt engineering is. Okay, so prompt engineering we will be using ahead also. It was just a brief introduction. Then we saw how we can build our own chatbot using Streamlit. Okay, Streamlit, like, it is little bit little bit faster when compared to Flask. If we use some of web apps, like we can use Flask also, we can use Django also. So compared to Flask, Django, when it comes to web app, using Streamlit is little faster because it runs directly from the command line. It can directly talk to hardware. Execution of code will be easy. So better to use desktop applications, okay, or web app. Streamlit we can use. So today we will understand complete retrieval augmented generation, RAG, okay, in depth. Okay, in today's session completely RAG we will finish off. Tomorrow we will do the same practical using Na10 without coding. Okay, today coding will be involved completely. How we can build RAG using Langchain and Llama index, both the frameworks we will use. And tomorrow's example, we will see complete automation using Na10. Okay, we will create an account and we will build a RAG model completely. So let us understand. Okay, I have PPT for this. Okay, so why we need RAG? Very simple, explanation. Okay, so basically when it comes to RAG, na, just use this. Okay, so traditional LLM, okay, face limited challenges when relying on pre-trained models without external knowledge access during inference. Okay, there is no external source. If I ask ChatGPT what was my electricity bill in the month of November, it doesn't know. Okay, it is not built on my model, my data itself. So to solve this issue we have RAG. Okay, so that I can train my LLM on the custom data, on my data. Okay, that is what RAG is. So every business requires this solution. Okay, and one more thing, you were telling that you want to be the part of this Python training previous one. I am uploading every video on YouTube once again. Okay, same Dubai guy I'm taking, and also one US guy has joined. So three people batch. I'm putting all the videos in YouTube, like Python, object oriented yesterday, modules and all. Okay, so if you want to go ahead and go through the backside explanation, also you can do that. Okay, instead of their class timings are different. Morning it is live. Morning 10 to 1 hour, so 10 to 11. So anyway, I'm recording. Next, it will be uploaded in LMS also. From there, you can have access. Okay. See, traditional LMM, whatever I'm speaking, okay, may produce incorrect or fabricated information. That is true. Information, whatever it will hallucinate. Okay, often outdated generic, okay, or generated output may be verified. It might not be from the authoritative sources. Okay, so for this now solution is our RAG completely. Okay, RAG, what it does, okay, RAG overcomes this challenge by connecting LLM to the trusted external knowledge base in real time. This is also called as, okay, this is also called as knowledge base. Okay, we will give our knowledge base to the LLM model. I'll show you how the things works. Okay, I have a beautiful architecture explaining how exactly RAG is working. Okay, we will connect our external knowledge, then this ensures current information, accurate information, and all those things are being done. Okay, this is simple thing, I guess you already know about it. Next, okay, so let us understand about RAG still more depth. Okay, RAG enhances large language model outputs by retrieving and grounding them in authoritative external sources, improving accuracy. Obviously, this is done. Okay, RAG brings in up-to-date domain-specific knowledge for relevant answers. It reduces hallucination. Main thing. Okay, so main thing is it reduces hallucination. Okay, hello. Yeah, sir. I'll tell you. Yeah, I'm recording it. I'm on YouTube. Yeah. Yeah, you want to join now? Okay, sure. Sure. I'll share you the link. Huh? Okay. 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 So obviously there are benefits with RAG, okay, because all business companies, whatever are there out there, they are working completely on RAG solution. Okay. If I just build a chatbot, okay, just a chatbot might not serve my business purpose because my chatbot is trained on limited data. One thing, okay. So usually many companies have their own chatbot. If you go to Amazon, it has their own chatbot. WhatsApp chatbots are getting integrated, but chatbots are only trained on limited knowledge, and every time you have to train, train. Okay, so in order to avoid this kind of over dependencies on chatbot and training, okay, we have RAG. Simply what we will do, okay, we will upload our document which will contain everything about the company, everything, like its vision, its mission, what are its refund policy, what are this that everything. 100 pages document I'll prepare for my company, and I will upload it in the RAG pipeline. So basically my LLM will not hallucinate anymore. Okay, so before giving the answer to the user, it goes inside the document. Okay, that's what vector embeddings. I'll explain you how vector embeddings works, how the vector databases get stored, and all semantic search how it happens, and it retrieves the information, passes to the LLM, and gives the response. Okay, so RAG is like complete solution to build a very huge, very big custom chatbot. Okay, like it will be trained exactly how it is supposed to answer when somebody visits your website or a company. Okay, so this is very important concept. Okay, main is this one. Okay, RAG architecture. If you understand RAG architecture, rest all things are easy. Okay, so see, there are two important steps in RAG. Okay, first, of course, the full form of RAG is retrieval augmented generation. Okay, so you're retrieving something, you're generating something. Okay, so first thing, what I will do, I will upload my knowledge base, as I told. Okay, suppose I have a training institute, right? So what I will do, I will upload everything that is related to training institute, what all courses we offer, what all prices are there, what is job job oriented program, and what is skill development program. Okay, so everything I'll upload in the document and I'll keep it ready. Okay, so I can store this knowledge base in Google Docs, okay, or some third party application, okay, or maybe in Google Drive also it may be, okay, or some kind of pipeline. If it is there, we can use S3 buckets also, we can use S3 bucket, Google buckets, anything. Okay, we will store this document somewhere. Okay, next part is in RAG we have to break the documents, because if I upload 100 pages of document, obviously I cannot feed entire 100 pages in my LLM. So I need something called as chunking. So chunking will basically break the documents into chunks. Okay, suppose if there is 1,000 lines, okay, I will break it into 200 each, 200 each, 200, five chunks I will do. Okay, so that easily it can be tokenized, and then it can be converted into vector embeddings and all those things. Next, something called as embedding model. So what is this? Okay, so I'm going in technical here completely. I'll explain how this embedding model works. Okay, so what I will do. Okay. Okay. See, when I talk about text embeddings or vectors, this is the language of LLM. LLM cannot understand English. Okay. LLM cannot understand large language models. NLP, natural language processing. Okay. LLM can only understand numbers. Okay, it may be computer also. Computer cannot understand English and all. It has to be converted into binary, zeros and ones. Okay, for quantum computer it is qubits. Okay, similarly when it comes to vectors here, okay, vectors also, whatever text we give. Okay, suppose I give the text. This is a cat. Okay, so basically what is happening, this is the cat is getting broken into tokens first, getting broken into tokens. Okay, so this becomes one word, is becomes one word. Okay, a becomes one more word, cat becomes one more. So it is broken down into tokens. Next, this tokens gets converted into something known as vectors. Okay, so vectors in the sense I will give some random number. Okay, minus 0.8. Okay, 2.5. Okay, 0.7. Okay, 7.8. Okay, some 128 vectors, something like this, some random numbers. Okay, so this is what is called as embeddings. Okay, these words, whatever words are there, it is broken down into vectors. Okay, and it is given to the embedding storing. I'll tell you. Okay, now what are these vectors? Okay, in maths now we have studied about something called as coordinates, graphs. Okay, so imagine, suppose I draw something called as cat here. Okay, so if I talk about Gemini, okay, Gemini has around 2728. I don't know, I'm not wrong, like I'm not exactly correct. So it has 728 dimensions, it seems. This is three dimension. Okay, X, Y, Z. Imagine 728 dimensions, multiple 728. Okay, in this dimension space the words are spread. Okay, when I talk about OpenAI, OpenAI has 1024 dimensions, still more than Gemini. Okay, dimension in the sense where these words are placed in the graph. Right now, I can only draw 3D. Imagine 124 dimension, 3 dimension I can draw. 124 is huge. Okay, suppose this is a cat and pet name is Kitty. Okay, so because of these vector embeddings, and they have trained these vector embeddings, okay, you can resemble Kitty to be somewhere near to cat. Understanding, right? Kitty to be somewhere near to cat. Okay, here this side it may be pen. Okay, here it may be male, here female. You're able to understand. Yeah. This is what close vectors are. Name place animal thing. Yes, correct. Name place animal, like noun concept. Okay, wherever there is similarity, the vectors are very close to each other. That is what this is. Okay, so if I say open this thing at 728, for this it is 1024 vector embeddings are there. Okay, so what happens is this embeddings vectors needs to be stored somewhere, right? So whatever, see, when I pass my document, my knowledge base about my company, this docs should also be getting converted into vectors, because that is the language of a LLM. I cannot give directly text. See, when you upload a document inside ChatGPT also, it gets converted into embeddings. Okay, we don't see, we only see the front end part, so back end part is huge. Okay, when we want to build our own RAG model for our company, okay, what we have to do, the document that we take needs to be converted into vectors. Okay, so like this, for every chunk there will be vectors like this, and these vectors, whatever it is there, okay, these vectors needs to be stored in vector database. Okay, so these vectors I cannot simply convert it and leave it. I need to store this in some vector database. It will be a number format. Yes, it will be in the number format. Okay, I cannot simply go and store it in RDBMS. It doesn't support. Okay, I cannot store it in the MongoDB. Okay, no SQL. Okay, I can store these vectors in some third party popular tool. Okay, right now we have ChromaDB, we have Pinecone, okay, we have Supabase, PG, Postgres, Supabase is there. Okay, there we can go and store this vector embeddings. Okay, so once again I'll repeat, whatever docs we upload, these docs needs to be converted into chunks. Okay, these chunks needs to be converted into embeddings. These embeddings need to be stored in vector database. This is part one of RAG. Able to understand? Okay, so docs, chunks, embeddings store in the vector DB. Okay, for vector DB we have ChromaDB, Pinecone we have Faces also by OpenAI. Okay, there are some models in the market which are publicly available. If you go to Hugging Face, there is a website called as Hugging Face. If you go to the Hugging Face, you will get a lot of embedding models only, whose work is to convert the text into embeddings, vector embeddings. Simple. Okay, so this process, okay, they have trained model in such a way that for cat they know this is the vector, for kitty they know this is the vector, for animal whatever it may be. Okay, so there are models such a way that we can directly use test embeddings. We will do it in one practical. Okay, and tomorrow, trust me, if this coding part is understood, n10 becomes very easy. Tomorrow is just drag and drop. Okay, I'll show you. Okay, I'll show you. Yesterday we built one actually. So this is Supabase. Okay, can you see vector embeddings? This text, Google is one of the most influential. Okay, this is the vector embeddings for that. Okay, I cannot see this. Okay, have you used this Supabase? No. I'll copy cell and I'll paste it somewhere.
This is Superbase is like
See, this
just
is,
its own.
huh?
Superbase is separate entity.
Yeah,
Okay.
yeah,
So
which is offering a database for vectors, for rows and columns also. It is, I think, something. It is extension of Postgres SQL or something like this. See, can you see this? This particular text has been converted to embeddings.
in the decoding, is there any again decoding in the shared
Yeah, yeah, I'll explain that. Okay. So decoding is not required because this is what AI LLM will understand. Okay, I'll tell you what some of these things there. Okay. Okay. So understood, na? Text is converted into embeddings. Okay, this is done. Now, yeah, I wanted to show you this. Minute 10. See, we built one rag. I think, can you see this rag? Hmm? One, this is NA10 workflow. Okay. Similarly, MCPs.
is open source anytime.
Actually, only 14 days are free. Okay. See, I have created one MCP server. Okay.
It is an orchestration tool also.
Sort of orchestration, you can say. Okay. See what I can do now. Instead of handling multiple Google calendars, okay, what I will do instead of giving it to AI agent, what I can do simply I can use MCP, put it in a MCP server, okay, and just use MCP and trigger it. Simple. It is very easy actually. Lot of automations are there in this. See, this is one RAG model actually. Okay, Postgres, simple vector store, Supabase. We can use Google embeddings are there. Okay, so whatever you upload on WhatsApp chat. Okay, you can build your own kind of RAG model in the WhatsApp. Okay, many things are there using this. Slowly exploring many things in NA10. Okay, okay. See, we wanted to, if you want to build a chatbot, just use WhatsApp trigger. Okay. Here you can use anything. Okay. So Google BigQuery is there. Okay.
What
Okay.
will be it will going to do? You just send a message. So
It will
you,
it will automate the workflow. Pipeline is what we were saying, na CI/CD pipeline you can say. But here now complete automation is there. You can link different components with another component. See, Google BigQuery is there. Okay, execute a query, insert in the table row. Okay, so here you can use, just open it, and you can connect your credentials with Google account. Okay, then Google run. Google lot of products are there. Can you see Google Cloud Language Tool? Kate, they have integrated or no, I don't know. Kubernetes are not. And they're slowly integrating many things. Okay. So let's see many workflow automations we can do using NA10. Okay. And it is self-hosted also. Okay. Like a very awesome tool in the market. Okay. So this embeddings is done. Okay. Now this is part one, as I told. So what is the part two of it? What is the part two? I'll use different ink altogether. Okay. So part two is what? User puts a query. Okay. User query should be converted into embeddings,
the laptops.
vectors. Suppose what is the vision of this company? Okay. He's putting a query. Query has to be converted into embeddings. Okay. Because when I talk about this embeddings, na, it is stored in the database. So this is vector DB. Okay. So what it does, this embeddings, okay, goes and searches in vector DB. Okay. So here now, here my chunks of document are there, and I'm asking it what's the vision of the company. So Once these both are present in the same vector db, okay, pay attention here. So here embeddings are converted. What is the vision? I have already put a vision of my company. So here there is something called as semantic search happening this way.
This will play that role in semantic search.
Yes, semantic search will help me to search the right keywords to get the information. Later, this information is being passed to LLM, which LLM vectors can understand. Anyway, it has LLM transformer architecture. It needs embeddings only. Okay, you don't have to transform it, or sorry, or decode it. Okay, anyway, you have encoder decoder architecture in transformer. Encoder decoder will automatically break down, pass it through the attention, I have told na, self attention mechanism, this transformer architecture. It gets passed through multi-level perceptron NLP, and it gives the output. This is how RAG works. Okay, so tomorrow if we want to build our own RAG, it may be using coding or it may be without coding, so we need to know this process. Okay, once again, part one is document. We have to chunk it, convert chunk into embeddings, store the embedding somewhere. Done. One part. Second part, user will do the query. Query is converted into embeddings because of the embeddings, it can do semantic search in the database. Okay, gets the information, passes to the LLM, and gives the output. Okay, this is what I wanted to explain through this particular architecture. What happened? Okay. So knowledge base, chunks, embeddings, store the embeddings. Okay. Now user query, convert into embeddings again. Query gets also does the semantic search. See, used to search through the vector database. Okay. Now same retrieval is there, pass to the prompt. Okay, used to the LLM, and output is done. Okay, this is how the LLM RAG model works. Mixed. Okay, so what are the use case? Very important, where all you can integrate. Okay, one thing is customer support. Huge customer support. See, nowadays now lot of some companies are also doing manual work, right? So their automation we can do. Okay, automate chat box provided accurate access. See, chatbots are there since 10 years back, but accuracy, when it comes to accuracy and all, it was little lagging behind. Now since AI is there, RAG is leveraging the power of AI. Okay, so then knowledge management. Okay, for this also we can do search enhancement. This is also one application of RAG. LLM augmented search engine provide context answers along with traditional search. Okay, like context based answers is what we can see. So what are the databases? Now we have to know, and like which one to choose when there are so much in the market, which is the best one we can do for. Okay, see, you have Pinecone, very famous, but Pinecone is very costly. Okay, so Pinecone hosted on cloud, hybrid limited. It is a purely like use. Preferred is 3 star. Best for scalable applications. Okay, huge business solution. We can go for Pinecone. We have Wavelet also. Okay, Wavelet is like hybrid. Both this thing you can use, and for hybrid searches use Milvus. Same thing. Okay, the interested vector database we have to know is one is Pinecone, Wavelet, PG vector. Okay, Redis can also be used in memory, very fast caching. In memory caching is there in Redis. Okay, ChromaDB. ChromaDB is like only for to build small kind of applications. Okay, if you just want to learn RAG, you can go for ChromaDB. But for the production, I prefer Pinecone. So, okay, so for tomorrow's exercise, for N8 exercise, I'll be using both Supabase and Pinecone. We will see production graded also, and we will see a little bit of advanced RAG also using Supabase. Okay, so this was about the theory part. So now I think this is understood, right?
Yeah.
So now let us do the practical part. Okay. So please create a folder in the local. Okay. Name a folder rag using Langchain. Come inside it. Done now. Okay. So open in the command prompt. Type code space dot. Okay. Yes, I trust author from the source. Okay. First thing, VS Code is opened. Okay. What we will do, we will create a file first. First, what we will do instead of creating, we will go to terminal and create a virtual environment. So I'll select command prompt better. Okay. So check Python version what you're using. I'm using 3.9. Okay, better to have a lower version,
Yeah, 3 points.
3.11. Okay.
No, 3.9.
Okay, awesome. So now Python hyphen m venv. So it will take some time. So until then, what we'll do, we will create requirements.txt. So I'm going to paste this. Please write it off. Okay, requirements.txt.
Plus,
Yeah, splitters for chunking. Okay, Langchain completely. Langchain Hugging Face also. Okay, Langchain has lot of integration. So here we'll use ChromaDB. Done now. Make sure the spelling is correct. Okay, working phase, sentence transformers we will use. Okay, and enter. So now pip install -r requirements requirements.txt. Pip install -r, okay, requirements.txt. Okay.
Activate
Did
is
you activate?
no, no, no.
Okay, please activate. Mine automatically it got activated. VNV backslash scripts backslash activate. Scripts activate. Don't put activate.bat, activate only is enough. Activated. So you should get VNV here. Okay.
Yeah, yeah.
If you're a Apple user, okay, you can go for source, then bin, then activate. Okay. Pip install -r requirements.txt. So it is installing ChromaDB, sentence transformer, NLTK, Langchain community.
ChromaDB, I think there's a which I could not find the version of satisfied.
Check the spelling. Chroma, CHROMADB, ROMADB. Okay, save it. So all the packages are getting installed.
Still, I couldn't find the version satisfied. I mean, Langchain.
Wait, I send you this completely. Okay, 3.9 only, na, you're using.
3 point, same version, 3.9.
Okay.
But use Chroma, not ChromaDB. The requirements is Chroma.
Chroma only. Langchain -chroma you have used?
Yeah.
I have. I've sent in WhatsApp. See, check,
No,
check.
same thing.
Same
Initially,
thing.
it was a ChromaDB.
Huh. Now it is Chroma,
Chroma.
but it is getting installed in my system.
Yeah. Now it's this time.
Okay.
It's throwing error like if you add ChromaDB,
Huh.
Langchain ChromaDB,
Huh. Oh, you have added Chroma DB there.
DB.
Ah, that's why. It is only Chroma. Here it was there, no? See, huge packages are there. If we use Vertex AI, I think it comes pre-installed there. Some packages might not be pre-installed. We have to use requirements only. Databricks, Azure Databricks in PySpark, though, but Databricks clusters are very fast. The StyleGAN 3 image generation itself, a huge model it is. If I had to run in normal, it would have taken 3 to 4 days. In that, only 10 to 12 minutes. Image is generated. Very huge model. Because it divides the work into two clusters. Now, Hadoop architecture it takes. It's nice actually.
Spark.
PySpark. Yeah. PySpark and SQL also we are using.
Should put a new banner outside for this internship. Now
Internship.
season, no, internship
Yeah, internship.
that
So
is now people will roam
yeah,
here. December starts means.
that's what they have told the BTO in websites. If it is registered, you can go and do. You have registered our company. Their BTO, it is their
People
portal.
who are coming from outside.
Ah,
They can see outside the banners.
correct.
Internship. And Microsoft then the good thing is VS Code.
There is one more ideally which is out by Google, anti-gravity killer.
But the market I see out of 100 members, 80 to 90% use
VS
VS Code.
Code only, yes. Yes.
Supports all Ruby,
Everything,
simple,
everything it supports.
modeling,
Very big, very good ideally actually.
CI/CD work.
Correct. Okay. Oh shit, some issues I got. Setup.py installer. This is an issue with the package mentioned above not picked. Okay, the directory name is invalid. Running. Okay. Mm, you are also getting the same error.
No, still it's running. Here is the Chroma DB.
Langchain
After Langchain, I have to open a Chroma DB.
here, no?
Uh,
So Chroma DB doesn't work.
it's not.
Okay. Mhm.
No, here Chroma DB is there.
Hmm.
Langchain underscore Chroma is there.
Underscore Chroma is there. Okay. Okay, there is some issue with the. You are using pip version, however, this is okay. Okay, never mind. So we'll change the structure completely.
Both one and the same. No? This one is new.
This one is different. This is a working one. This I had built, I think, some 4 months ago. So, I think that is going to fail. Because I'm going to show how to load data from different source also. Okay, not just we will give document. If you want to load it from website, if you want to load it from JSON, okay, we will see those things also. So I want you to prepare one file, that is data ingestion dot ipynb. We'll create a notebook. Please install this.
Should I wait and
No, no, you control C you can do, because anyway the setup is failing. Because you will see all other databases also. Yeah, vector databases, ChromaDB is there, Faces is there, then Wavelet also will come. Yeah,
yes.
it will come fastly. Still not installed.
Yeah, mine also it's
Same thing. Because we have to know some different sources how we can take knowledge base on that. So I'm like, I need to show this.
Even if you have like the file also you can share.
Which one?
IP
This
value,
one?
IP value.
Yeah, I have. Share that. Once this is installed, we'll quickly do it and wind up.
Then
The thing is, I should make it run actually. Mm, not installed yet. How much time?
05.
This packages keeps updating every month. Some requires build, some hange it will install. Okay.
Done job for me.
Done. Yeah, wait, so installed, huh? Successful.
Yes.
You got this setting, running, setup.
Okay.
See one more thing. What structure have been done? This one you have installed, no?
I'll 22. Maybe before I log in, I restarted all applications.
Oh, could be you feed your memory.
Usually, I just I see a lot of Windows were running on my system.
Oh, yeah, correct. So my RAM is heavily working.
Maybe 20 to 30 websites are running.
Correct. No worries. Okay. So we will select the kernel. Please choose Python kernel and choose on click on recommended. Okay. The version of Python associated with the kernel is no longer, so please consider a different kernel. Okay. Okay.
Some text is there.
Hmm?
Text file is there.
Where? Yeah, yeah. Speech.txt. First loading from speech, then XML, then attention PDF. Okay. So this is what we will be doing. Rag. Actually, I had built Rag from scratch also. That code also I'll send. Okay. So it does embeddings and all. NLTK, you see this one explanation. Yeah. Into Rag from scratch. So just a brief explanation. See. Okay, PDF chunking, embeddings. Okay, build semantic search, and give it to LLM. Okay. So this was the document knowledge base. Obviously, I have to convert this into vector element. This is my query, and this is the document. Okay. I used this collection counter, convert into tokens, splits. Okay. Document token this also. Now use a counter how many times that word appeared. Okay. Same for this also. Then I'm joining the token, putting it in the this thing. These are my vectors. Okay. Printing the tokens, my list. Then dot product. Obviously, semantic search it is done through dot product only. Okay, you have cosine similarity index using I told you now relation mapping. Okay, my query and the knowledge base mapped through this only. Uh, mm, your cosine similarity. Okay, this is the formula for that. Very beautiful concept, Ragis. So this is cosine similarity for semantic search. Okay. Then tokens it is printing. It is doing dots product, and if it is near to one, that means both the words are related. Okay. Magnitude because square root if you do now it is I'm getting something called as 3.4. Okay, so more the similarity that means the words are similar. Okay, 3 here the similarity is less 0.17. Is yoga good for health? Document also yoga is good for living. Okay, let us see its dot product. You will get something called as 0.6 that means near to 1, so similarity is there. Then I like fresh air, I like to do yoga. Then, if I ask to respond, take a yoga class and stretch your body and mind. So this is what locally built, without using any text embeddings, without using any LLM. Okay, just pure mathematics. Okay.
Usually, if you see core also, they will be based on this only what we are doing.
Yeah, 100%. So in this one it will be okay. I think my this thing is installed. Okay, so let me test print. Oh, sorry. Okay, hi. Okay, it is working. Okay, I'll share you this. You don't have to type it down. Oh shit, I should have done it here. No problem. Okay. So first from Langchain dot document loader. Okay, this is the function from Langchain dot document loader. Import text loader. If you have a knowledge base in the .txt format, you use text loader function. Okay, you had built on this thing, na project. Tomorrow after NA10, try with NA10 once. Okay, and try how you can do automation from there. Complete. You had done using notebook, na? That was only the backend part. For NA10, you tried to do tomorrow. Okay, so if you want to load text document, okay, text loader, you pass the .txt, okay, .txt file. I'll upload it in the group channel. Okay, don't have to worry. And this will load the entire text and give me the output. Okay, suppose I want to see the text what it is there. Okay, you have something called as loader.load function of this only object. Okay, this is the function. Okay, so if I want to check, so this is what it is. The world is must be safe for democracy. It is a peace and planted. Okay, if I open this now, this is the text of this was said by some politician. Okay, understood. Now this is like I'll put text markdown also. Loading the document from text. Okay, next what we will do. Okay, reading from the PDF. Okay, suppose you have PDF and you want to read that. Okay, you have something called as, oh, sorry, this is not a code. Okay, you have something called as PyPDF loader. Okay, for text you have text loader. For PDF you have PyPDF loader. Okay, I have a PDF attention that all you need, famous PDF which revolutionized complete LLM architecture. Okay,
So it will go to store on the
yes.
data frame or like how it will store
No, it will
text
store in the textual format.
yes.
Yeah. See, I'll pass you and I'll show.
Images also.
No, images. We don't need images now for RAG.
No,
Okay.
I'm talking about the images are there. No?
Images will be ignored. Images will be ignored. So here, what it does, na, it will do OCR. Okay, optical character recognition. Image is converted into text. Okay, that is what OCR is. Okay, if you want to convert PDF to Word, PDF is nothing but it's a scanned image. Okay, PDF you Word when you do the conversion from image, the text data is extracted and it is converted. Okay, so please update that this is just a warning. Okay, see it is reading the entire PDF. Okay, so PyPDF loader is there. We have installed it in the requirement here. PyPDF. Okay, okay, so it is loaded. Then I can see document dot load. Instead of DOS, I'll give, then I can see PDF also. So this is the PDF. See, very huge. Okay, so it has broken it like this.
Page one
Provide
zero.
your attribution, Google.
Zero page has this one. Page one
Page
has
as this one. Okay,
right side we have page.
correct.
Here you
See,
have page
page,
labels. Page one,
page
page two.
labels it has given, page
Three
15.
pages.
Okay, like this. So images are not present in this. Okay, because we don't need images for RAG. Third, this thing I'll close. So we saw how to load from PDF. Okay, suppose you have Okay, you can use type function from web if you want to load from website. Okay, if your knowledge base is from website, some people have the knowledge base in website. Now, what it does about us, contact us, this thing, that thing. Okay, I can use web based loader. Okay, web based loader, and this is some GitHub post. Okay, I'll just show you. So this is about the website. How this is about air this thing. Okay, some LLM pod automation agents, how to build this memory, short-term memory, okay, long-term memory. Okay, so if I want to load this directly, I'll use this web loader PDF, right? Loader dot this. Okay, then loader dot load I can use, and I can see the post. Okay, I've already loaded it. Now, okay, if you want to load it from the publications, okay, there is one famous publications for as Arxiv, RXIV. Okay, so it is like a paper publication for PhD and for academic people. ARX, spelling of it. ARXIV. So paper publication basically. Okay, whatever research you do, okay, from there also we can load in our LLM. Okay, simply run this. So I can ask it to load how many pages I want also. So this is the query. I should give the number, okay, document number, and it will search and it will give it to me. Okay. So then I can print docs and all, not required. Okay. It's from Wikipedia. If your knowledge base is from Wikipedia, Langchain has the loader called as Wikipedia loader. Okay, Langchain is very huge library, very awesome framework for RAG. Okay. See, generative AI, okay, documentation. If I want to read from Wikipedia, I'll load it. See, I got generative AI or simple AI pornography. What it is showing? GAN, okay. Source and all. See, huge content is there. Okay. Now we have seen the data loading part. Okay. Now we have to split the text chunking. Okay. Basically, let us see chunking now. So there is another function called as recursive character text splitter. Recursive, go back, split it, go back, split it, go. See what is the chunk size you want. Okay, how many parts it wants to break. Okay, if I give 500, like 500 pieces of chunks will be there. Okay, chunks can be decided. Okay, overlap 50. If I give more pages gets loaded. Okay, 50 in the sense very less page. Okay, then I have to pass this docs or PDF. Okay, I have declared docs right somewhere. I think I did PDF here.
PDF.
Okay, I'll load this PDF. Attention, all you need. Okay, and if I see final documents, so this is what it has
PDF.
chunks. Chunking it has done. Okay, if you increase the overlap, some more words get added in that one chunk. Okay, after 50 words, next 50 words next. Okay, so we can use this recursive text splitter. Okay, for this thing. Then you have text loader. We have seen now already.
It is this
Okay, for this we will use again speech. Okay, let's load this speech on it. Becomes easy for the understanding. I'll read it in speech. Okay, simple Python code. Only speech I'll extract and I will chunk it and show. Okay, this will be easily understood. Okay, so I'll pass this speech. Now you can see the world must be safe for its peace must be planted on the tested foundation of. Okay, found it. Till here it has splitted. If I increase the overlap to 30, some more words gets added. Wait, I'll increase the chunk size also. See, some more words got added. Okay, so let me make it default. Then if you want only one thing, this same thing, you can use either characters text splitter or you can use recursive text splitter. Okay, I'm not going to explain anyway, it will be there in the documentation. I can use HTML splitter also, not much used. Okay. Okay, now very important concept, embeddings. Okay, so I'm going to load the API keys. Okay, so I'll create .env. OpenAI API that I will use. So Llama also I don't have. I have Hugging Face. Okay, okay. So we'll use Hugging Face token. Okay, for embeddings. I think I have already .env. I'll load the same one. Okay, you can create account on Hugging Face. It will give API general API key we can put. Okay, let me use this. Okay, so I'll import this HF token. Okay, from there, then I'll use this model from Langchain. For embedding also, you have one model from Langchain Hugging Face embeddings. We'll use that embeddings, all mini this thing. Okay, it's going to download that model for me. Using API, I'm fetching the model. Okay, take some time. All mini 4 LM model. Okay, okay. So I'll paste this. Okay, this is the text document. Let us see what is the embeddings it is going to give. This is the embedding for my
Text.
text. Okay, let us see the size of it. Okay, if I do length now, it is giving me
Number of lines.
yes 120 138
Yeah.
vectors. Okay, for this particular word. Hmm? Obviously now we'll see vector database very important. We have to store this, right? We have to store this in vector database. Okay, Facebook's similarity search. Okay, faces clustering dense vectors into we'll use this faces. So we will use this once again, all these things. Mm, okay, instead of OpenAI embeddings, I'm going to use character text splitter, faces database, and we will load all these things. Okay, we will be using since OpenAI embeddings requires API key, okay, paid one. So I'm going to use Hugging Face, face embeddings. Okay, so from document, I'll put DOS and I'll put embeddings in DB. It will be stored. Okay, okay. Faces it will store in the data vector database. Now they store in some address. Okay. Now let us do one query and see. Okay. How does speaker describe the desired outcome of the word? Okay. db dot similarity search query and it will give me the content. It is a distribution and opportunity. See, whatever I have in the thing now, same thing I can get it from there. Okay, rag. Okay. Now we can build a retriever also. The same principle. Okay. For that again we have chroma db. Okay. We can use chroma, we can put the text db. Okay. I have uncommented it. Okay. You can comment it and you can use it as a retriever. Okay. Then we can pass it to the LLM and get the response from the LLM. Okay. Okay then. So I'll share you this one. So I'm going to. I'll share you, Sanal. Okay, all the documents, whatever it is, on WhatsApp.